Alright, so here was my number 2, 9x squared times y minus 5 over y equals 0. So if I want to find the dy dx, the slope generating function, I will take the derivative of each piece. So I got this minus this. I'm not going to try to solve for y and get that out. I just want to take the derivative of each of these pieces. So when I'm looking at this one, I see a product rule, right? So I'm going to take the derivative of the first. So I'm looking at that is 1 and that is 1. So again, the product rule. So I'll do the first times the derivative of the second, which the derivative of, again, make sure you realize that this is a my d's look like 8 sometime. dy dx. So the derivative of y is dy dx. And I'm going to add to that the derivative of my first term times my second term. Now, you may be asking, well, what's the derivative of x? And we've always said that that's just 1. But officially, there's like a dx dx. We wouldn't write that. Change an x over change an x, it's the same thing. So we typically don't write that. But when we're taking the derivative of y with respect to x, when we look at the word problems in the next section, that'll make a little bit more sense. We would write the dy dx. So this is the derivative of that first piece. And this one is minus 5 over y, which is the same thing as minus 5y to the negative 1. If I'm taking the derivative of that, I'd get plus 5y to the negative 2. And again, I'm taking a derivative of something with y. So whenever you have the derivative of something with y, you put dy dx. And this equals 0. So I have this equation with x's and y in it, but what I really want to know is dy dx. So now I would group the things that have dy dx, which is my 9x squared, plus my 5 over y squared. And I'm going to go ahead and move that 18xy to the other side. Alright. And to solve for dy dx, I would just divide both sides by 9x squared plus 5 over y squared. And this isn't the exact thing that my WebAssign showed, but it is a manipulation. They got a common denominator, but WebAssign would take this. This is the derivative of y with respect to x of that initial implicit equation. The other one that I wanted to look at is number 6. So it actually gave another implicit equation. And again, if we graph this, you could graph it on Desmos possibly, and see that it's not a function, but it's an equation. And then whenever we find the derivatives, they want us to find the slope at this particular point, negative 5, positive 5. So we have to take the derivative of this piece, and then we'll take the derivative of that piece. So this first one, this looks like a chain rule to me. So you might be getting better with the chain rule. So 3 times x plus y squared times the derivative of the inside, right? Because that's what my u is, if I'm doing the substitution. And the derivative of x plus y is 1 plus dy dx. So the derivative of x is just 1, the derivative of y is dy dx. So that's where my derivative of my substituted thing is. Equals, well, the right hand side is pretty easy, 3x squared, and this would be 3y squared. But I'd have to do my dy dx. Whenever you take the derivative of y, you will have a dy dx. So now my job is to get all my dy's dx's on the same side. Might be easier if I go ahead and distribute this. So I get a 3x plus y squared dy dx equals 3x squared plus 3y squared dy dx. So now I'm back to the same thing. I want to get all of my dy's, dx's on one side and then divide by its coefficient. I think it might be easier just to move this one over here. So I have 3x plus y squared. I'm going to go ahead and bring my 3x squared over here. So minus 3x squared equals, so both those terms that I'm going to have on the right hand side are going to have that dy dx now. So I'll have a 3y squared minus 3x plus y squared. Looks like I wrote it down wrong here. Again, it should have been, when I distribute it, that's 3 times x plus y squared times dy dx. So apologies for that. My next step would be to divide everything by all that. So I'm going to end up with dy dx equals my numerator, which is that piece right here, 3 times x plus y squared minus 3x squared, all over 3y squared minus 3 times x plus y squared. So this is my slope generating function, right? Or equation in this case, since I have x's and y's. And now the last thing I need to do is plug in my negative 5 for x and my 5 for y. That's going to help me find my slope. So, very nicely, negative 5 plus 5 is 0, so those cancel out. So we know those are zeros. Awesome. So when I plug negative 5 in for x here, I'll get negative 3 times negative 5 squared. On the bottom, again, since this is a big old 0 and that's a big old 0, I just have this 3y squared, so 3 over 5 squared. Checking my math, I think we're going to end up with a big old negative 1. And good, that's what the WebAssign got as well. So at the point negative 5, 5, so graph that equation on Desmos, plot your point, negative 5, 5, and the slope of the tangent line is going to be negative 1.